Welcome back to my channel Physics Foundation Mastery Hub. Thank you for being here. In this particular video, I'm going to explain a very important concept called image formation. I'm going to discuss what actually an image is, and then I'm going to discuss how it is formed. Many a times, unfortunately, students apply different formulae present in this particular chapter like lens formula, mirrors formula, lens makers formula, blah blah blah, etc., without actually understanding what an image actually is and how it is formed. In fact, even I was in the same situation when I was a student. I did not understand them clearly. Somehow I just knew how to apply the formulae and I could solve some numericals. I got some marks and I got some ranks. However, I did not really learn the subject well. I don't want that kind of situation to be present for other students, present students. So I'm going to clarify those doubts of what exactly an image is and how it is formed through this particular video. Let me explain what an image actually is. There are two aspects to image. First aspect is we see something, it appears to be there, but it is not really there. For example, when I stand in front of mirror, I am here, the real me, hello, I'm here. But when I look into the mirror, I appear to be present somewhere behind the mirror. I see myself inside the mirror. I see, but I'm not present there. I'm here. I see something, but it is not actually there. This is one of the aspects of image. I see something, it appears to be present, but it is actually not there. That's an image. Second aspect is an image always indicates the presence of the object. So when I see myself in the mirror, basically what I see is indicating the presence of reality. Okay? Image always indicates the presence of a reality. Another example is when your father is driving a car, he keeps looking at the rear view mirror to see if there is any vehicles coming from behind. What your father sees a truck coming. So he sees the presence of truck within the rear view mirror. But by the way, where the truck is somewhere behind. Okay? So what is this truck? Truck appears to be there in front of you, but it is not there, but it is there somewhere else. This is the first aspect. Let me give you another example. When the letters are very, very small within a book, so we use a magnifying glass and you place the magnifying glass in front of the small letters and I see the letters becoming bigger and you can easily read. Now, are there really any big letters? No, all the letters are small, but the letters appear to be magnified. Big letters. So big letters are appearing to be there, but they do not exist. So this is the first aspect or first definition of image, I can say. You see something, but it is not present. It is not really there. That is an image. That is number one. Second aspect is image always is a distorted version of reality. Let me go in the same sequence of examples what I'm speaking. When I'm standing in front of mirror, what do I see? I see myself inside the mirror, right? That image is indicating a reality, but that image is a distorted version of reality. Why do I say distorted? Distorted basically means a changed version. My right appears to be left within the mirror. My left appears to be the right within the mirror. So left, right has changed. Also, my position has changed. Okay, I am standing here, but my image appears to be somewhere else. Okay, so image is a distorted version of reality. Just like when father is driving, what he's seeing within the rear view mirror is the truck is very, very huge, but he sees truck very small within the mirror. So a distorted version of the reality is basically an image. So image, the two properties, it appears to be present, but it is not really there. Second is, it is basically a distorted version of reality. Now the question is, how are the images formed? The answer is, images can be formed both due to reflection as well as refraction. Let us see one by one. Let us understand how images are formed due to reflection. Let us start with plane mirror. Let us say you have an object, and when light falls on the object reflects that light, and that reflected light, when it reaches my eye, let us say this is my eye, and some light is falling on it, and this object is reflecting light, and the reflected light, when it reaches my eye, I can see the object. Okay, what is this? This is basically reflected light. This is reflected light. Who is reflecting? By the object. However, every time instead of saying reflected light, I prefer to say light coming from the object. Of course, object is not giving out light. Object is only reflecting light, but I can say that this light is also light coming from object. Don't confuse. It is not that the object itself is giving light. It is only reflected light, just like moonlight. Moon is not giving its own light. Moon is only reflecting the sun's light. But then we say moonlight. Similarly, this is actually reflected light. However, we to make the discussion simple, we'll say that this is light coming from the object. Now, the light coming from the object is very, very important. Why it is very, very important? Because this contains all the visual information about the object. I give this example actually. Like, let us say you have flower, and a breeze or air which is flowing on top of these flowers, when it enters my nose, I get the information about the smell, right? So the breeze carries the information about the smell. Similarly, the light coming from an object contains all the visual information about the object. When I say visual information, what does it mean? Color, position, size and shape. All these information we get through this rays coming out from the object. Very, very important. The light coming from the object contains all these informations. Alright. Now let us say we have a mirror here. We have a plane mirror to start with. Okay. So what's going to happen? Light is falling on the object. So the object is going to reflect, is going to give out light in all possible directions. Now, you also will have some rays which are incident on the mirror. Is it not true? You'll also have some rays which are incident on the mirror. Now, I hope you know the basic laws of reflection, which is angle of incidence is equal to angle of reflection, and the normal incident ray and the reflected ray, they all lie within the same plane. I hope you know that. Now this is one ray, and let us consider you have another ray here. Now what happens? Now as far as this ray is concerned, now again I am going to tell you, this light which is coming out from the object is very, very important. Why? Because this light carries the visual information about this object. Alright. Now, at this particular point, this is called as point of incidence. At the point of incidence, if I draw a normal to the mirror, that is called as the normal. This is the point of incidence, and this is basically the normal. And this is angle of incidence. Now, where will the reflected ray be? Reflected ray is here. The reflected ray is here, such that angle of reflection and angle of incidence are the same. Similarly, as far as this ray is concerned, so I'm going to just draw it arbitrarily. So this is the reflected light. This is the reflected ray. Now my dear friends, please try to understand. What are these rays? It is not just two rays actually. You have so many rays in between as well. Okay. These light rays contain the visual information about this object. Similarly, these two rays, it has just got reflected. Even these two rays also, basically, what are these two rays? These are reflected rays. But these rays are coming from where? This object. That means these reflected rays also contain the info about whom? Info about the same object. Info about the same object, sir. Alright. Now, these two rays, when they are reaching my eye, okay. When these two rays, when it is reached by eye, my eye is receiving the information about the object. Now, I want to say another very important aspect. What is that? Our brain is designed in such a way that it believes that light can only travel in straight line paths. Very, very important. So these two rays, when it is received by eye, what's going to happen? Our brain is designed in such a way that light can travel only in straight line paths. That means when these two rays, when it is reached by my eye, reached at my eye, what happens is my eye, my brain, the entire system feels that these two rays must be coming from somewhere here. So it's basically kind of extrapolates. Because see, very important thing. What is that very important thing? It is this, that my brain strongly believes that light can only travel in straight lines. So I see these two rays, okay? And what my mind understands, hey, light only can travel in straight lines. Okay, where are these two rays coming from? By the way, mind you, it is not just two rays, you have infinite number of rays in between as well. Okay, these two rays basically are the boundary lines, you could say, the boundary rays. So these two rays, where are they coming from? So my mind feels that these two rays are somewhere here. So I feel the brain perceives. Now what will you see here? You will see the same object. Why? Because what are the rays which are reaching your eye? These are the rays which have the information about the object. But where will you see the object? You will see the object here. Why, sir? Because the way our brain is created. The brain strongly believes that light can only travel in straight lines. So because these two reflected rays, they appear to come from here, I see a ball here. Actual ball, which is basically the object, is here. But yeah, I see the object also, but I also see an image here. What is this? This is the image. This is basically the image. Object is represented as O and image is represented as I. Of course, through geometry we can prove that the distance of the object to the mirror and the distance from the mirror to the image, it is the same in case of plane mirrors. So this is how I see an image behind the mirror. We have seen how an image is formed of a small ball, we can say a point object. Now we are going to see how an image is formed of an extended object. Extended object is an object with finite size. So here is an object. The bottommost point of the object I am considering it as A, and the topmost point in the object I will consider it as B. Now, when light falls on the object, every point is going to give a diverging beam of light. How it is, I have already explained in one of my previous videos. The link for it, I'll put it in the description box. Please do watch. So what happens is when an object is illuminated, every point on the object is going to give out a diverging beam of light. So that means from A you are going to have a diverging beam of light, and from B also you are going to have diverging beam of light. Now, how many rays are going to come out from each point? You have infinite number of rays will come out from each point on the object. But in order for me to trace, in order for me to understand the position of the image, I just need 2 rays. Just 2 rays. That is sufficient. Now let us start from B. Now let us draw any 2 rays from B. So one ray, I will take a ray which is normally incident. So any ray which is normally incident, it will bounce back. So it bounces back. This is reflected ray for this incident ray. Similarly, you have another ray which is incident on the plane mirror here. And how is it going to get reflected? This is the normal. This is the point of incidence. This is the normal, and is going to get reflected. It's going to reflected like this, such that what has to happen? This is incident angle. Angle of incidence must be equal to angle of reflection. Very nice. Now these 2 reflected rays appear to come from where? These 2 reflected rays. So this ray appears to come from somewhere here, and this reflected ray appears to come from somewhere here. Alright. So these 2 reflected rays, actually they are coming from B. That means these 2 reflected rays contains the information about B, and when my eye receives these 2 rays, what does my eye see at this point? It sees B. It sees B. Of course, it doesn't see B, it sees the image of B. What I see here is basically image of B. So I'll represent it as B dash. Similarly, as far as A is concerned, let me take a ray which is falling normally, which is going to bounce back exactly. It will traverse backwards. And let me take another ray. So it's going to get reflected. Yes, sir. Now these are the 2 rays which are actually reflecting, and if these 2 rays reach my eye, so where do these 2 rays appear to come from? These 2 rays appear to come from here. So these 2 rays appear to come from here. So what do I see here? I see actually these 2 rays are actually coming from A, and these 2 rays only are getting reflected. So these 2 rays contain the information about A. So when these 2 rays arrive at my eye, what I'm supposed to see? I'm supposed to see A only, but where do I see A? I see A here. Is basically A dash. So here is where I see the image. AB is the object, A dash B dash is the image of the object. So the image formed by plane mirror, it will have the same size as that of the object. That is one property. The second property is this distance, the object to the plane mirror, this is called the object distance, and the plane mirror to the image is basically the image distance, and object distance happens to be always equal to image distance in the case of plane mirror. Also I said the size of the image is always same as the size of the object when it comes to plane mirror. So, and another thing is, this image appears to be present because of these reflected rays. Okay, these 2 reflected rays, of course they are not 2, there are infinite number of reflected rays. So there are infinite number of reflected rays. When these reflected rays are arrived at my eye, I see this B dash. But these reflected rays actually they do not actually meet at B dash. These reflected rays these two reflected rays, they do not actually originate at B dash. They only appear to be originated from B dash. Similarly, here also, these two reflected rays, they only appear to be coming out from A dash. So, such an image is called as virtual image. Such an image is called as virtual image. So if I say that there is a virtual image, that means an opposite of virtual image, which is basically real image, also must exist. Right? So I'm going to put up another video about virtual image and real image, the differences and how to understand about both of them. I'm going to make another video. Thank you so much.